Hey everybody, it's the 23rd of October, 2024. This is Plutus project-based learning from Gimbalabs and friends. And we talk about all the time how this course is called Plutus PBL, but really it's about generally getting into Cardano development. And today we're going to have a working session where we go through some examples in the last module that we still have to publish from this course, Validator Essentials. What we're going to do is actually look at validators in Aiken first. And this is a bit of a change for us, right? Again, we know the course is called Plutus PBL, but we also recognize that Aiken has built up a strong reputation. And I think in a lot of the experiments we've all been doing, we've found that it's maybe a better or at least more accessible starting point for people. The key thing here is that just like Plutus TX, Aiken compiles to untyped Plutus core, right? On the blockchain, we still have the same compilation target. And so technically, we can argue that we're still talking about Plutus either way. But if you really want to learn Plutus TX instead of Aiken to write your validators, all of the concepts we're going to cover here still apply. No matter what on-chain language you're using, you got to know about datum. You got to understand this idea of redeemer and understand how parameters work, for example. Some of the details will be a little bit different. The way we compile contracts is different. The way we write error traces can be different between Aiken and Plutus TX. But by looking at this, we're going to have a chance to get into some of those details. And if there's anybody looking at this video later or moving through this course in the future, and you want to see these examples as Plutus TX, I hope you'll reach out. That's something that we can absolutely build if we have a good reason to, but we really want to try to get feedback from people who are learning to figure out what's most important here. Any questions about that high-level view about how we're going to look at Aiken in order to learn Plutus? And the topic today is validators. Okay, so interrupt anytime. All right, you guys know that sometimes I get going on a code example and I forget to breathe. So please just interrupt me. It's really exciting to be interrupted and to hear that people have questions. So the lesson content we have right now is in development, but the code examples are ready to go. And we're going to spend a little bit of time kind of thinking together about what the lessons need to say. And I'll even refer to the current drafts of these lessons just so we can see where we stand. Colin, welcome. It's good to see you here, man.
Hey, oh,
We're jumping into
all
validator
right.
development, and the only rule is just feel free to interrupt anytime with questions. Okay.
Yep, no, and mostly I'm here just to watch and hang out, see you guys. I'm driving into work right now, so
Nice. All right. Hopefully we'll give you some good ideas.
yep.
All right. So we've got 7 learning targets. There used to be fewer, but I decided to split them up a little bit. And just reviewing these learning targets for a moment, we're going to build upon an example that's already in the Aiken onboarding docs. Essentially, we're going to be playing with the idea of a vesting contract. And just to be clear about terminology, when we talk about vesting, what we're really talking about is time, right? And we're going to build through a series of examples a validator that validates successfully after some specified time. By starting with a really simple example, we're going to go through some of the patterns about how you compile and deploy it on chain as a reference script. And then one step at a time, we're going to build up the example, adding features to it to make it a little bit more realistic. But at every step in this process, we're not quite going to be building a validator that I would recommend using in production. This is not just like grab and go code that you can drop into your $1 million dApp, okay? This is code that helps you understand some concepts, but in order to bring it to production, you're probably going to want to add a little bit more rigorous logic to this thing. And you'll see what I mean as we go through it. Now, we've covered some things already in this course, and that's what the introduction here says. You can see it's not published yet, but I wanted to take us through the current draft. Some of these lessons have more draft content than others. And my goal, like I said, is to get it right. I want to try to figure out the right amount to say without saying too much. So this is a little overview of what I said at the beginning, right? We know this course is called Plutus PBL, but we're covering a lot more than just Plutus TX. Really, our goal is to help people start building applications on Cardano, give you a survey of the field, give you mental models for what you need to learn, and then show you how to start putting the pieces together. Now, we've already compiled some on-chain validators. This concept was introduced back in Module 101, where you got to see how to compile your first smart contract in Plutus TX, Aiken, PluTS, and we even explored Helios. Again, all of these compile to UPLC. I'm also using this word validator. Maybe you've heard it, maybe this is new. This is a more precise term to use than smart contract. Smart contract, we got that terminology from the Ethereum development ecosystem. When this idea was invented, it was absolutely revolutionary. And we still use this term to talk about building dApps, right? Building applications on the Cardano blockchain. But this term doesn't really map directly to any formal structure inside of Cardano development. It's just a loose term that we can use to talk about like an amalgamation of things. It's much more precise to talk about validators. And by the end of this module, one of my primary goals is to make sure that you have a really clear idea for what a validator is. And we're going to start looking at these right now. You could see this word in a lot of the learning targets and even in the title of this module, Validator Essentials, right? At the end of this module, you're going to be ready to start building the app that you can imagine. You're going to be ready to jump into projects, maybe start contributing by building out these examples and thinking of other examples that will be helpful to students. And you'll have some ideas for why we have focused courses about Mesh and Aiken PBL, for example. We're not going to cover all of Aiken. We're going to give you a place to get started. And maybe you might even get frustrated with some of the busy work I'm about to show you and wish there was a better option. Because as we're doing things the long, inefficient way here, because we believe that's a good way to help you learn by getting hands-on, you might realize, hey, wouldn't it be better to use automated testing than to build test transactions? And the answer would be absolutely. And so what we're about to do is build some validators, and we're actually going to test them directly on the pre-prod network. But as you'll see, that doesn't lead to fast development. And if you already know what you're doing with transaction building, you're not going to want to do these steps anymore. That's when you know you're ready to jump into the Aiken PBL course, where we don't build transactions, we only create tests of mock transactions using Aiken's built-in testing framework. So a lot of background right there. And these are all concepts that we're going to return to as we start to jump into these lessons. So let's look at the first example for just a second. And I need to through here. Okay. So we're going to build first a really basic validator that only accounts for time on its own. And if you were here last week, you saw we had a chance to kind of play around and think about the different starting points for thinking about validation logic. And in this one, hopefully you can see the validator on my screen right here doesn't have many lines of code. So let's look at a few of the key concepts. This is Aiken code. I'm going to open it in VS Code in just a minute so we can play with it. But a few key things to see. The keyword validator is used just like the word function might be used in JavaScript to specify that we are defining a validator. It's really elegant, right? Okay, I'm going to write a validator with this name, and the code for this validator is right here. Inside the validator, we're going to talk more about this else statement in lesson 205.3. But inside the validator, we want to be able to look at the different purposes for which a validator might be built. And we're starting with, as this lesson says, an all-purpose validator. Why do we call this an all-purpose validator? Because of this line right here, where we're not actually specifying a specific purpose. We're just saying, hey, you can use this validator for any purpose as long as the on-chain time is after some specified time. Now, what is this string right here? Okay, that's why this link is provided in the documentation. Let's open it up. Okay. So this time right here is called epoch time. You might hear it referred to as Unix time, but in any case, it's the amount of time that has elapsed since the first day of January in 1970, okay? And sometimes you're going to see this term POSIX time. We'll talk about that more in just a second. The most important difference is that Unix time is measured in seconds, whereas POSIX time, which is what we're going to use right here, is measured in milliseconds. And that's why you see the 3 extra zeros. If I take this timestamp and I just paste it into the epoch converter here, it translates it into a human readable date. And you can see that the date in this example was actually last week, October 14th, 7:41 my time, 11:41 GMT. Okay, so what does this mean? This means that I could actually use this validator right here as an always succeeds contract because it was locked until a time that has already passed. That means that anybody's going to be able to unlock UTXOs from here right away. We're going to go into the code and change that in just a minute. But before we do, hopefully you're noticing 2 more things. One, we have a helper function right here. This helper function must start after is going to be reused in every one of the examples we work on in this module. This is provided in the Aiken documentation as an example. And what it does is it takes a validity range. We'll talk more about that validity range in just a moment, and an expiration time, which is an int. The expiration time that we're passing as the second parameter right here is this lock until value that I just talked about. The validity range is coming from our transaction context. And this is the first critical concept I want to introduce you to. in any validator, for that validator to be useful, you have to use the validator in some transaction. Without a transaction, a validator doesn't really do much. And this is similar to how, without a transaction, your private signing keys don't do much. When do I need my signing keys? I need my signing keys when I want to sign a transaction. I don't need my signing keys to look at the balance of my wallet, right? I don't need my signing keys to kind of see any status on chain. I only need them to sign a transaction. And for a validator, it's the same case. Yeah, Harsh, I'll zoom in. For a validator, it's the same case. I only need the validator when I'm trying to unlock UTXOs from a transaction. So I can assume that this validator is going to be used in some transaction. And we call that the context. What is the context in which this validator is being used? So let's look at the documentation for just a moment. I'm going to head over to the Aiken website. This is really well organized. The Getting Started guide, I think everybody should take a look at this. And we're not trying to replace this in any way. We're really just trying to complement it with some hands-on ways to get started. What I'd like to point you to is the standard library. It's linked here at the top of the page or down here at the bottom in quick links. And the standard library documentation gives me a place where I can go a little deeper and I can see how Aiken works. Now, I see that there's a library called Cardano Transaction. Let's see if we can find where transaction is defined. Here it is. For just a moment, just read through this, right? What does a transaction include? And hopefully you're not surprised by a lot of these ideas. You've already seen that a transaction must have inputs, a set of UTXOs, and outputs. There's always going to be a fee associated with the transaction. The transaction might mint some new tokens. It might include some reference inputs. And then moving on through the list, right? Maybe it has some certificates. This has to do with delegation to a stake pool or to a DREP or to registering your ability to stake in either of those cases or even to create a stake pool, okay? That's always going to be a valuable thing, but we're not going to cover that too much right here. Here's the validity range that we just saw in the example we were looking at. Signatories, right? Anytime you hear about multi-sig, this is just representing that a transaction can be signed not by just one party who's unlocking the inputs to a transaction, but you can require many parties. Datums and redeemers, we're going to look at those today. A deterministic transaction ID, right? Any transaction based on all of its other fields is going to have an ID. Voting, proposals, these are new after the Chang hard fork. And then some treasury stuff that we're going to have some fun playing with soon, but we're not going to touch these yet. Behold the transaction, here it is. Hey, Faizan, hey, Caesar. Any questions about this transaction constructor that's on my screen? So we've got transactions. And again, the validator will be executed in the context of some transaction. And that's what we're looking at right here. Okay. One of the things that we can look at in a transaction is the validity range. And we can always use this destructuring pattern right here. This is similar. If you are familiar with TypeScript, this should look familiar. In most languages, you have the ability to take an object and destructure it in this way, right? Of course, I could pull all of these record fields in, but I don't have to, because for my particular validator, I only care about this bit right here. However, at any time, if you wanted to look at the inputs, the outputs, or mint or fee or any of this stuff and validate against it, you could. You could add it to this destructured list right here and then use it just like we were able to define validity range this way and then just use it. Any questions about that bit?
Yeah, just a quick question for me. So I understand the concept around destructuring. Next to the validity range, there's two dots. What is that doing?
This is called a spread, and it just
Oh,
says, yeah, all that other stuff is there,
okay,
right? But we're not going to pay specific attention to it. And what this allows me to, I'm actually not sure if that has to be there or not. Let's actually see if we get an Aiken error if we leave that part out. And so, yeah, now's a good time to jump into the code itself. And so this is, first of all, I'm in VS Code and I have two directories ready to go locally. These are both the public GitHub repos and they're up to date. On Gimbalabs GitHub, we have PPBL 2024 Aiken examples. You can clone this, and if you already have, just make sure to pull down the latest updates. And same thing, PPBL 2024 transaction examples. We're going to start here with the Aiken examples, and these are organized by lesson. The only lesson that doesn't have one is 205.2, and you'll see why in just a moment. But we can look at the first example, 205.1, and all validators are going to be written in the validators directory. And this code should look familiar from what we were just looking at on my screen. This has a few extra comments in it. We didn't paste all of those into the lesson, but here's our helper function, and here's that source code. Let's try something. I'm going to change directory into SLT 205.1. This is, oh, and then one more into introduce transaction time. There we go. This directory has the aiken.toml file in it, and it has my top level validators directory. So this is where I can run different Aiken functions. If ever I run an Aiken function like this, Aiken check, it's going to first check to see that there is a toml file in the directory where I'm running this from. And as long as it sees that, it'll go through the rest of the process. So real quick, let's delete those dots and see if it complains. Yeah, okay. So those are required. This is one of the things I do like about Aiken is the errors are helpful. While trying to make sense of your code, I saw one field where there should be 16. Right, okay. So for destructuring, we just have to acknowledge that those other 15 fields exist. And it looks like the way we do that is by having that spread operator. Check again, and we're fine. Now, we talked last week a little bit how you have to bend your mind to think about how time works. And so this function might take a few minutes of thinking to understand what's happening here. The validity range has an upper and a lower bound. And I'll show you how to define those bounds when we build the transaction. But for now, understand, right, this is a range. And then we're passing a single int. And we're saying, okay, in that range, check first of all that the lower bound is finite. So there must be a lower bound. If I do not specify a lower bound in my transaction, that means it's infinite, right? There was no time before which this transaction was valid. In other words, infinite. We want there to be an existing finite bound to the transaction, and we're going to call that the TX earliest time. Then, once we have that bound, we're just going to compare it to the expiration time. And the expiration time has to be less than or equal to the earliest time that the transaction was possible, right? How do you feel about the logic here? So here's a Boolean statement, when this returns true, then the whole function will return true. And when the function returns true, that's actually essentially the return statement of this validator right here. Okay, so if this is true, the whole thing is true, and our validator succeeds. If this is false, then must start after returns false, which means our validator returns false, and the transaction will not validate. We will not be able to build a transaction. And then, of course, if we have anything other than a finite lower bound, right? This says the lower bound is finite. In any other case, just fail, return false. I'm not going to look at this function closely again, but if you need help just thinking through it, let me know. So let's look at a few more things. Now let's get into the Aiken toolchain a little bit. We have some very simple validation code right here. And our goal is to be able to use it on chain. Here's what I'm going to do. First, I can run the function Aiken build. When I do, once again, the checks will happen inside of Aiken. Of course, if Aiken check does not pass, Aiken build won't either. And what this does is it takes my code and it says, generate a project blueprint. It creates a file that by default has the name plutus.json. And the file looks like this. This is actually a wonderful step towards a kind of more robust development ecosystem for Cardano. No matter where the on-chain code was written, it would be really nice to have a way to share that on-chain code between applications. And so this, I forget what number it is. I think this is SIP 59. Anybody know that off the top of their heads? I have to double check, but there's a SIP for this blueprint. You can find it on the SIPs site. We can go look for that in just a second. And there's a couple things we see here, but most importantly, we see that we have a list of validators. Now this list has just one object in it. The title, you can see the file name, then the validator name, then the purpose of that code we were just writing. Let's look at this again. So the file name inside our validators folder was introduce transaction time. Then inside that file, we created a validator that actually had the same name, but it didn't have to. And inside that validator, we defined one endpoint, the else endpoint. And so when I look at this file right here, for the title of our validator, that's what I see. File name, validator name, endpoint. And in the next example, you're going to see that this list of validators has more than one object in it. And these titles will make even more sense when we look at that. This validator does not have a redeemer. We will introduce this a couple lessons from now, and it does have compiled code. Here it is. This is the byte string representation of the untyped Plutus core that we will actually be able to use on the blockchain. We write all of the logic in a nice human-friendly language so that we can end up with a nice string like this that can be used on chain. And as we move through this process, you're going to see a couple more ways to interact with this compiled code, but this is the basic idea. There's also a hash right here. If I wanted to use this validator to mint tokens, I would need to know the policy ID that this validator was going to generate. And that policy ID is always simply the hash of the validator. In other words, this code right here could be used to mint tokens that can only be minted after a certain time. Now, if you're following along, you recognize that this time right here is hard-coded. Let's get a more realistic time, because even this time is probably not as recent as we might want it to be. Let's see. Yeah, that was a couple days ago. Let's build a validator that's going to lock until 15 minutes from now. Here we go. I'm going to use this timestamp instead. And I'm going to go back here and change that value. Then I'm going to grab this hash right here, and I'm just going to write it into a comment in the code so we can look at it again later. And now I'm going to run Aiken build again with my very similar but slightly different validator. Remember this one, DDF6 was our hash here. If I look at the Plutus JSON file again, the hash is now different. Just by changing one number in a validator, I get a completely different hash. And that's a really good thing. Any questions about that idea? I find this fascinating, right? I could create a minting policy with this policy ID. And what does this policy ID happen to represent? It represents a token that anyone could mint after 13:20, 3:25 in the afternoon, UTC time, right? On this day. Right? And if I change this by even 1 second, or even by 1 millisecond, that would be enough to do it. Watch, I'm going to run Aiken build again. And of course, I watch that hash or policy ID change. Now, ultimately, we're not here to build a minting validator. You're going to see more about that in a moment. We are here to build a validator where we can lock some UTXOs until a certain time. In order for that to be useful, we need more than just the compiled code and a hash. We also need an address. So that's the next step I'm going to do here. I've already run Aiken build, so I already have the plutus.json file. Once I have this file, I can now use a command from Aiken blueprint. Aiken blueprint has a few different subcommands: address, policy, hash, apply, convert. We're not going to cover all of these right now, but you're probably starting to have some ideas about how this works. What I'd like to do first is just create an address. Aiken blueprint address. This is an address, looks just like any other blockchain address, but this is an address where you could lock UTXOs that could only be unlocked after this time. If I change this time, once again, even by a few seconds, and if I run Aiken build, then Aiken blueprint address again, you can see that now I have a different address. And I want to say it over and over again. In your wallet address, the way to unlock UTXOs is by signing with your private keys. In a validator address, there are no private keys. There are rules. And this one has a very simple rule. You can't unlock it until this time and date. How are we doing so far?
We're going to be able to see this, watch this again. Will this be up on the channel?
100%. Yeah, we're live streaming right now to the Gimbalabs YouTube channel, and all of this code is available in the Gimbalabs GitHub. Okay. So, in order to interact with this address, which was built from this validator, we need to go send some tokens to this address, and then we need to try to unlock them. But before we do that, there's one more thing to learn. So let's jump back to the course outline, right? So this, you can see this lesson is partly written, and I want to clean up these steps, but really step by step, this is what we just did. I showed you Aiken check, Aiken build, and Aiken blueprint address. I showed you that we can change the lock until value and see that it creates a different address each time. And I mentioned earlier that after that deadline, technically this kind of becomes an always succeeds contract, right? It doesn't really, this is not very useful. I'm just showing you this to introduce transaction context and this idea of time, but we haven't used it yet. So what we're going to do next is look at how to deploy this script on chain and then practice using it. And that's what lesson 205.2 is about. So in the rest of this module, we're going to add features to the validator that I just showed you how to start building. And in the lessons that follow this one, you're going to repeat the steps we see right here over and over again with different features each time. You'll need to compile the validator. That's what I just showed you, right? Aiken build, and then Aiken blueprint address. We can mess around with the code. I hope that this code makes you curious enough to try to break it, see what you can do with it, try to extend it, try to make it do something else. And then we need some transactions that help us interact with it. We're being inefficient on purpose. If you remember elementary school and how you used to have to do math worksheets, this is similar. We're going to have you do things the long way, because what we've found teaching this course is that when people build transactions by hand, they build up some muscle memory for steps that are really essential. By practicing this with the provided scripts, you're going to have a better understanding once you move into application development. That's our goal. I want you to have a really, really strong mental model for how validators and transactions work. Like I mentioned before, if it's successful, you're going to get tired of testing things this way. And when that happens, that's a good thing. That means you're ready to jump into the Aiken PBL course, look at automated testing, and to move beyond this. Now, in order to test things by hand, we need to deploy a reference script. So what's that? Well, once we have our UPLC, we can save it as a file that looks like this. But we haven't done that yet. So let's see how. I already showed you Aiken blueprint address, but there's another command that we might want to use. Aiken blueprint convert. Watch this. This takes our validator from this file right here, and it turns it into the kind of Plutus script file that if you've already completed like module 101, you might be familiar with this, right? This is the format that Cardano CLI looks for when we're building transactions. And this is the format that can be deployed on chain. So obviously when I run Aiken blueprint convert, it just prints this to my terminal window. But what I can do instead is I can say echo, and then this command, Aiken blueprint convert. And we're just going to save this to a file. The file name really doesn't matter, okay? But just to keep things organized, I'm going to call this file slt2051.plutus. You can call it whatever you want, and even the .plutus extension doesn't matter at all. It just helps us stay organized. I run this again, nothing printed to the terminal, but now I have a nice, here it is, SLT205.1 file. And I could, let's see, can I format this as JSON? How's that? Yeah, it's not formatted automatically, but that's easy to do as well. And the spacing doesn't matter. I'm just cleaning this up so we can look at it together. There we go. Good enough. Right. I'm not going to do this for the future files, but just to review, here we go. Right. We have the type. It's Plutus v3. That matters. This is different from Plutus v2. There's a description. This is just arbitrary. It's fine to leave this empty, but it's nice to know that this was generated from Aiken. And if you're writing a full-fledged application where you have many validators, it's likely that you'll want to keep some notes for yourself. Right? So I could write a note right here, and it doesn't make a difference. This is just notes that you'll be able to see and reference. Module 205. Great. Okay, so this is the script file that I need, but let me one more time. I want to make sure that I have time to do this for this to fail, and that's only a few minutes away. Let me buy myself 5 extra minutes by changing this timestamp a little bit. Go back into the code over here and replace this number once again. Sure. Run this Aiken build command again. Great. And then run the blueprint command again where I save it. And now I've got an updated file here that I won't be able to unlock from until 8 minutes from now. Let me see if I can move quickly through these next concepts in the next 8 minutes. Now that I have this file, I want to use it in a transaction. So here in my repo navigation, I'm going to move on from the Aiken examples for just a minute and switch over to transaction examples. All of the examples from earlier in the course are still here. We are focused on module 205 right now. And you saw earlier that we have examples for every lesson but 205.2. This is where we're introducing what I'm showing you right now in the transactions. Following lesson 205.2, you'll see that there are corresponding folders in each of these repos. So we have validators for the next 5 lessons and transaction examples to go along with those. When we're testing the validator, we're going to use these scripts right here. And we've got our locking and unlocking scripts that we'll look at in just a moment. I'm going to delete this file because this is from a couple days ago when I was testing this lesson. Remove that. But now whether you want to do it from the command line by using the CP command Or since I have a nice UI right in front of me, I can just copy this file and I'm going to paste it right here. Cool. Excuse me. I have an old transaction that already worked. I'm going to delete that because we're about to build some new transactions. Great. So I've got this Plutus file. That's all well and good, but it's not yet available to me on chain. So the next thing I need to do is deploy this script. And a helpful script is provided right here. Once again, I'm in the repo, I'm in module 205, and here is a script that will deploy a reference script, okay? All I need to do is tell it on the command line the path to the validator I want to deploy and the minimum amount of Lovelace that are required. Cool. Let's try running this thing. I'm going to jump over to a terminal. Okay, so this is the same repo that we were just looking at. I'm going to cd into module 205, and then I want to use the deploy reference script that's at the top level. This takes two arguments, as we just saw, a validator path and some minimum amount of Lovelace. Let's first give it the validator path. That's going to be SLT 2052. No? There we go. There we go. And remember, we just moved this SLT 2051.plutus file into here. So SLT 2051. So there's the path to my validator that I'm going to put on chain. And now I need to define the minimum UTXO. Geez, I don't know what that amount is, right? Well, why does minimum UTXO exist? Well, anything we put on chain needs a minimum amount of ADA to allow it to be stored on chain. For a typical UTXO, the minimum is, I think technically right now, it's a tiny bit less than 1 ADA, 900,000 something Lovelace. But the more you try to put into a UTXO, the greater that minimum is going to be. And so what are some examples of things we can put inside of a UTXO? Oh, we could put some tokens, mint some native assets, right? And any UTXO that has multiple different assets in it is going to have a slightly higher minimum. We can put datum in a UTXO, which is the focus of lesson 205.5. You can see that right here. We're going to look at that in just a moment. Or we can put an entire script into a UTXO. That's what we're going to do right now. We want to take this Plutus script and put it on chain. Now, for a really big script, the Andamio team, for example, has written some validators where the minimum UTXO for putting those scripts on chain is almost 30 ADA. And if you're used to tokens, NFTs, that kind of thing, you're not used to seeing a minimum UTXO that high, but it's possible for it to be that high because a script can be really big. It could take up a lot of space. And if it does, it's more expensive. Now, once again, I actually don't know what the minimum is for this. So you know what I'm going to do? I'm going to cheat. I'm just going to say 0. I'm not going to include any Lovelace here. Now look for just a second, that min UTXO, remember it's the second argument. It's going to be used right here. What are we about to do? This is a pretty simple spending transaction. If you've already been participating in the course, you should be pretty comfortable with this format already. All we're adding is that we want to attach a reference script file to this output. Where is the output going? Anywhere. in my environment file, env.sh, I have some private keys, so I'm not going to show you that file right now. But in the documentation, there's a reminder that this is a prerequisite, right? You have to set up your own environment variables, and you'll see how to do that in the lesson. Needless to say, one of the environment variables is this reference script address that I define once right here, and then I can reuse over and over again like this. And this script won't work for you unless you do define that variable. This address, there's nothing special about it. It's just a regular spending address that I created with Cardano CLI. But a lot of people are doing some really interesting experiments storing reference scripts at validator addresses, which, think about it, does make some sense, right? If I'm putting a Plutus script on chain, I would like to have some assurance that nobody's going to accidentally spend it. And I've done this before. When I was first learning about reference scripts, I just kept them in one of my regular spending wallets. But then all my applications broke when I accidentally sent the UTXOs that used to include those scripts somewhere else, right? So that's why I've realized it's very, very helpful to use a dedicated address for this thing, just for the reason that you don't want to accidentally spend your reference UTXOs, right? Okay, now, because I'm attaching a script, it needs some min Lovelace. And like we just saw on my command line, I'm about to try this with a min UTXO value of 0. And of course, that's going to fail. I can't send 0 Lovelace in a UTXO. It doesn't achieve the minimum with or without a script. But errors are your best friend. If you're not sure what to do, try to get a helpful error that can point you in the right direction. Watch. This command failed. We tried, but the error was minimum UTXO threshold was not met for this output. Cool. Yeah, we tried to put 0 Lovelace there. And then it tells me, ooh, what's required? This much. Very nice. That's the number that I should have written in place of that 0. Let's do it. We're successfully submitted. This is what you see when the transaction builds successfully. This is what you see when it submits successfully. And finally, we can see a TX hash at the bottom because of this command that's included for convenience right here. What is this doing? Cardano CLI transaction TXID on a file. Which file? The file that I just submitted on chain. And this gives me the transaction hash. Why is that transaction hash important? Because this is moving forward what I'm going to use to interact with the validator that I just wrote. Watch. Going back to the code over here, I now want to focus on, we covered the reference script, and I'm not going to cover this again. You're just going to use this deploy reference script in each of the next 5 lessons, okay? And then once you place that UTXO on chain, you'll get the transaction hash of it, and then you can pull that in to these other scripts up here, locking and unlocking. So let me close my other windows for now and just open up these locking and unlocking transactions. Now, first of all, the unlocking one, the second one, this is where I need to specify the reference UTXO. So off screen, I'm going to copy that and I'm going to replace it right here. This is going to be used when I try to spend from the validator address. Spending TX in reference refers to this. And look how elegant this is. Once this Plutus script is on chain, I don't need to worry about that .plutus file anymore. I don't need to look at this again. All I need to do is know where it is stored on chain. I no longer need to, and I say this because this is how we used to have to do it in this course. Before reference scripts were added on chain, we used to have to add all these files to our Git repos and pass them back and forth to each other. But now we don't have to do that anymore, because once they're deployed on chain, we can just tell each other, hey, here's the reference script you need. Just use it in a transaction. And whether you're using Cardano CLI, whether you're using Cardano CLI or Mesh or any other transaction building library, the pattern is the same. It's really convenient and really exciting. So that's all good. But now we also have to concern ourselves with validator address. Where were we going to lock these UTXOs in the first place? That comes into play right here. We're going to specify a validator address. We're going to choose to lock some Lovelace. And then there's some utilities that just grab, for example, a UTXO from your wallet. Make sure to set your variables. Make sure to define your sender address and your sender key in the env file. And then this utility, which you can look at the source code for in utils.sh right here. Just a little helpful function that runs Cardano CLI. It queries the UTXOs in your wallet, and it gets the biggest one, the one with the most Lovelace. And we use that as our input. Just a little convenience right here. And you can write your own scripts, or you could even define these TXINs by hand. But to review, where do we get this address? Let's go back here, where we've already built a Plutus file, but I know that I've changed that value a few times of the expiration time. So let's do Aiken blueprint address again. And this is the address associated with the script that I just put on chain. And I realize I've already gone past my deadline. So actually this has effectively turned into always succeeds, but I'm still going to show you how to make it fail right now. So that's the address we're going to use. And we're going to run two transactions, lock and then unlock. Let's go back over here. First, let's say Cardano CLI query the UTXOs on preprod, testnet magic 1, at address, this address, the one we were just looking at. And no surprise, this is empty, right? Nobody's ever built a validator before that unlocked at the precise second as the validator that we just built. Okay, if they had, maybe we would have seen some UTXOs here. Great. So we have an empty address, and now we're going to lock some tokens in it. And the specific scripts are in these subdirectories here that are organized by learning targets, so you can follow along in order. So let's change directory into SLT 205.2. Of course, we can see the lock and unlock scripts that I was just showing you. And remember, number one has the two arguments, the validator address and how much Lovelace we want to lock. So let's run that. 001, lock tokens. And validator address is this guy right here. And how much Lovelace do we want to lock? Let's just do like 6.25 ADA. How's that? 6.25 ADA might look like that. I'm going to run this script. I can see that it built successfully, the low fee that I expect. This is just a sending transaction, and it's been successfully submitted. I can check my mempool to see when it validates. Here's that transaction going into the mempool with one transaction. Let's wait for it to come out the other side. There it is. Okay. So I can see right here in my node, now the mempool is once again empty. There's nothing there left, no number of transactions. So now if I query this address again, I ought to see a UTXO that has that 6.25 ADA in it. And there it is. Cool. Now, we'll talk more about datum. In this example, I just threw a number in there, elite, right? As the value. We're going to dive more into this in a few minutes. So I'm glossing over it for now, but you can see on my screen that this UTXO has the value that we wanted it to have along with some datum. There's the number. Okay. And our goal is to unlock this thing. This takes two command line arguments as well. The first one is the validator address like before. The second one is a slot. We got our reference UTXO already. That's good. We've got a helper function to get some UTXOs from both our validator address, where we expect this, and my wallet. And then we use the slot right here. Invalid before. Let's do those gymnastics again. This transaction is invalid before some specified slot number. In other words, I'm not going to be able to submit this transaction to the blockchain before that slot. And by defining this, I change from the default. What's the default? It's if I leave this line out, if I don't specify invalid before, then the validity range of this transaction is unbounded. It's infinite. That transaction can be built anytime. Once I specify this slot, now I'm satisfying, going back to the Aiken code, now I'm satisfying this constraint right here, where the bound, the lower bound, had to be finite. So I hope that's making sense, and I want to get better at explaining this because I recognize that time is always a little bit hard to talk about on chain, okay? But invalid before is what specifies the earliest time, right? The start of the range. Now, you can see I haven't specified the end of the range. The latest time this transaction can be used is infinite. It's unbounded. And if I wanted to bound it, here's what I would do. Cardano CLI, Conway, transaction build. Let's just look at the documentation. I know that there is an invalid before. That's the one I was just showing you. And then this guy right here, invalid hereafter, is what I would use if I wanted an upper bound on that validity range. Only the lower range matters. Now, here's the other thing that's hard about time. In our example, in the validator itself, time is represented by this absolute time number, right? This is a POSIX time, like I mentioned, from the start of the year in 1970. This is how many milliseconds have surpassed since then. This is very convenient for building any software is having a shared standard for how we talk about time. But if we're talking about blockchain time, we really can't use this. The blockchain runs in slots, and the length of a slot happens to be 1 second right now. A couple of years ago, this parameter was different, and the slot length was 20 seconds. So you had to do an extra level of arithmetic there. But now we have one slot is equal to 1 second. It may be like that for the long term, but it might change in the future. And it's relative to the amount of time the blockchain itself has been running. So when I specify invalid before or invalid hereafter, I'm going to do it in slots, which specify how much time it's been since this blockchain started running. And under the hood, based on the protocol parameters, that slot time can be converted to POSIX time so that our validators can validate, right? Can validate against blockchain time. But this is a really key idea that blockchain time and slots and the POSIX time that we use in our validators will be, that's a little bit confusing. And that's exactly why I'm trying to teach it right now. And you're going to see this example once again, repeatedly. So I hope this gives you a chance to get comfortable with these concepts. Where do I get the slot from? I query the tip of the blockchain, Cardano CLI, query tip of preprod. And right now, again, I have a node running right here. So I'm able to see, that the current slot is this, but I also recognize that I wanted to show you a failing transactions. That's what we're going to do first. Okay. 15 minutes ago, let me go 20 minutes back in time. 20 minutes is 1200 seconds. So I'm going to just subtract about 1200 from here. I'll subtract 2000. So when I run this unlocking script that's provided, I'm going to use the address just like a moment ago. And I'm going to specify a slot that says 7401. But instead of 5081, I'm going to write 3081. Right? And what's that? That's the number of seconds since the pre-prod network was turned on. And you could do the math yourself to figure out how many years are in this many seconds. All right? But for now, I expect my transaction, this transaction, to fail because the earliest time I'm specifying in my validity range is going to be less than the lock expiration time. And remember, for this validator to validate, the earliest time has to be greater than the expiration time. And that's why I'm going to expect this validator to fail. Watch. Let's run this transaction. And oh, script witness points to a Plutus script that does not exist. Oh, that is a different error. That's because I got confused between, let's see here. Okay, watch this. We just put up a reference UTXO 4A9B. Yep. And what I really want to do is so I'm running Cardano CLI query UTXO again, but this time I'm going to save the results to a file. so I can read them. I'm just going to call it ref utxos.json. Right? Didn't print, it's saved to this file this time. And let's say cat ref utxos. Great. And let's go find, so you can see that each of these has a reference script. And I need the one in UTXO 4A9B. That's this. With that min lovelies. But was this the same one that I was just building from a second ago? Okay, so the reason I'm getting this error right now is I think I might have. Oh, no, here's why I'm getting the error. Ha. I got that error because I didn't save this file yet. Okay, so this is great. All right, let me do this again. You see right here, a little white dot. I replaced the reference UTXO in this file, but I forgot to save it. And so, of course, it was looking for an old reference UTXO that's not associated with the address I was trying to use. Let's try this again. What are we doing here? Oh, now my computer froze. $205.2 once again. We're going to run that unlock tokens. And now I've saved the file correctly, but I'm hoping that this fails because I want you to see that validation is not working because of the slot we're specifying. Let's see. There we go. All right, so different error from last time. We can go back to the video to compare these errors, but this time the error says the following scripts have execution failures. That's a very good thing because we don't want that validator to validate if our validity range is out of bounds. Long story short, let's just fix this for now. We're going to have many more chances to use this. Let me just query the tip again. Now the slot is right here. Let's just use that number. And now I should be good because I think this validator that we wrote unlocked like 20 minutes ago. So we should be fine if we include this. And if I do, let's see. No problem. Success. What I really want you to take away from this lesson right here is, does success look nice? Yeah, of course it does, right? Okay, I got the transaction to work. It's submitted. Great. But this is where the good stuff happens. And when you're learning how to write and test validators, one of the things you want to do is make sure that the validators fail in the situations where you want them to fail. Because what's the alternative? If your validator doesn't fail when it's not supposed to, that means somebody's probably going to be able to unlock funds from you when you don't want them to. Your smart contract, your validator, needs to return false as often as possible. And it should only validate as true and submit that transaction in only the cases where you want it to. This is so important. So I could not recommend this more. Make sure that you get errors when you want to see them. And in the Aiken course, like I mentioned, we're going to show you how to build mock transactions to speed up this process quite a lot. You'll also recognize that this error message might not be too helpful. The scripts have execution failures, input 0. Okay, that was, my first input that I was trying to spend, sure. But it doesn't tell me what the error was. And that's why in lesson 205.4, we're going to show you how to write traces so that it's easier to diagnose the errors. And you're going to see when we create these errors, how the right messages pop up. Okay. That was a deep dive, but let's review again our goal. My goal is for you to learn a process that you're now going to be able to use over and over again in the next 5 lessons. I want you to be able to compile a validator. I want you to be able to play with the validator code, and I want you to be able to use the provided bash scripts. In order to do this, you'll need to be able to deploy a reference script, and I just showed you the provided bash script that allows you to do this. Then we talked about, oh, here's just the link to that shell script that we were just looking at, okay? And then we have examples provided for locking and unlocking transactions. Here's our unlocking transaction, for example. Nope, sorry. This is still the deployment transaction, for example, right? And this takes you through here, shows you how to set up the environment file. And then we go through those 2 transactions, okay? From compiling, well, this is just giving you more background. Yeah, I haven't cleaned up these notes yet. This is where I said, I'm not sure if I'm providing too much right here. And as you guys get into these lessons and read through, let me know what needs to stay and what we should remove. You could just use the chat at the bottom of the page and we can use this as like a live place to update. But a lot of this should look pretty familiar. And what this prepares us to do is to now repeat the process in the next few lessons. So I know we've only got a few minutes left right now. Feel free to drop off if you've got to go. I'm going to just go through one more example pretty quickly without annotating it as much to show you the next example. And then what we'll do next week, same time, is go through the final 4 examples. So right now we're going to move to lesson 205.3, where we're going to write a validator this time that has a purpose. We're going to build upon the vesting contract that we just started to build, but we're going to change a couple of important things about it. And I'm going to try to do this all in about 20 minutes. So we're going to go a total of about 15 minutes over for this session. But obviously we're recording, so you can catch up anytime. Let me close these current windows. Clear out my terminal, so that's cleaned up. And I'm going to move out of here and into SLT 205.3, where we're going to introduce this idea of purpose. Let's close this guy for just a minute and close that. Go into 205.3, introduce purpose, where just like in the previous example, there's a single validator. This validator is almost the same as the last one, except this time, if you try to use it for just any purpose, it will fail. In the previous example, we only provided the else case. Now we are making sure that you can only use this validator to spend. Previous example, if you tried to mint a token with it, and I recommend you do this, you'll be able to. This example, if you try to mint a token, it will fail. If you try to submit a governance action or any kind of credential stuff, or you can look at the other purposes in the Aiken documentation, none of those will work. But besides that, the logic is still the same. We're still using must start after. We're using it in the same spot inside of a spending validator instead of inside the else validator. We're creating a lock until time just like we were before. We're pulling the validity range from the transaction just like we were before. But right here, this is what's new. We have a signature for our purpose, which is spend. And whenever there's a purpose, there's a different set of arguments that it's going to take. And focusing for now on just the spending purpose, these are the 4 arguments: datum, redeemer, an output reference, and a transaction. Datum and redeemer are going to be the focus of the next few lessons. We're almost there. Input, we're going to ignore for now because that'll make this lesson go on for a little bit longer. And transaction is the part that matters to us. The way we represent that this is the only part that matters to us is by putting these little underscores on the front of the other 3 arguments. By writing underscore datum, I'm essentially telling the Aiken type checker to ignore datum, redeemer, and input here. If I got rid of these underscores, I would get some compilation and type checking errors because it would say that you have some unused variables. So you can use a leading underscore anytime you have a variable you want to ignore. We use transaction, we destructure it to get the validity range, and then we're off and running. Let's use this code to complete the exact same steps we did a few minutes ago. Oops, we're already in the right direction. So first I'm going to run Aiken check. And it checks out just fine. That's wonderful. I'm going to go in here and confirm. Yeah, I don't have a Plutus JSON file yet, so that's good. So let me run Aiken build, and I will see that Plutus.json file appear. Here it is. And unlike last time, when I look at the validators here, I'm going to see a list with more than one item. This one, introduce purpose, file name, dot, introduce purpose, validator, dot, endpoint. Look at this, is spend. And we have one set of code for spending and another set of code for everything else. This is provided here, but it actually is not useful. Why? Because it always fails, right? This else endpoint just fails. So basically, this compiled code right here is an always fails validator. We're really interested in the spending one. But an implication of this, if you're thinking creatively, is that all sorts of interesting logic could optionally go inside of this endpoint. I'll leave that to you to explore. We are really interested in this validator right here, and that's what we're going to use. So let's try to build an address from it. I already ran Aiken build. Yep, double checking. That looks good. Now I can run Aiken blueprint address just like I did before. But look, because there are multiple validators in this code, right? 2 different endpoints, spend and else, I actually have to specify which one I'm using. This wasn't the case before. If there's only one validator, it assumes you're talking about that one. So I have to change this command just a little bit by specifying which validator I want. And I know it's this one right here. There is the address that goes with this example. And that's really nice, but before I keep going, I should probably get a more current time here. Let's jump back to epoch converter. Let's try to get all of this stuff done in the next 13 minutes. I'm going to move fast. Famous last words. All right, that looks good. Grab that timestamp. Put that here. Save that. Aiken build again. And now let's write an address again. And hopefully this is no surprise. I can see that it's different. Great. Finally, I'm going to echo Aiken blueprint convert. Oh, that didn't pull in the right time. Introduce. You know what? I need to see that. Let's use this. Yeah. I just want to make sure I'm getting those file names right. So we're gonna wrap this in parentheses and we're gonna send it to SLT2053.Plutus. We're gonna wrap this entire command and echo it. But instead of getting the address, I want that Plutus script. That looks good. Here I have SLT2053.Plutus. No surprise, it's that same kind of script file that we were looking at a moment ago. And then I'll just use the convenient UI of VS Code to copy that Plutus file and paste it into this directory where we're going to work from now. I'm going to jump over to my terminal again. And this time I want to CD into SLT2053. Here I have a locking and unlocking and my Plutus script. And in order to be able to use it, of course, I need to deploy it. So this is in SLT2053. It's this script. I don't know how much the min UTXO needs to be. I'll say 0. Notice that this is actually a slightly lower minimum UTXO than before. I'll leave it to you to try to figure out why. But for now, great. I saved myself like 0.2 ADA by having a more specific validator. Very nice. I can deploy this. It works, and I've got my successful transaction hash, which I need in my unlocking transaction. So let's open up that unlocking transaction and take a quick look. This is actually not very different from what we were just looking at before, okay? The difference, let's paste, not that. Let's paste this guy, our new reference UTXO. I'm also giving myself a space where I don't necessarily have to make everything an argument. I can, for example, just take the validator address that was generated here, and I can paste it into this code. And I'm just showing you a few different ways of doing this, so you can choose the way that works best for you. All right, cool. Now I've got an address hard-coded into this script. I've got the ref UTXO I need. The only argument I'm going to have to supply is the slot. Wonderful. But before I can unlock anything, of course, I'm going to have to unlock tokens. And this one looks like the prior example, right? There's a validator address. I'm just going to copy and paste this guy and the amount of Lovelace, which can be whatever I want as long as it's more than an ADA. Cool. So let's use this script to lock. We'll check that address to see that it's there. And then we're going to try to unlock it. And this is going to be nice. We're going to beat that deadline. So we're going to see it fail. We're going to wait a few minutes, and then we're going to see it succeed. Let's jump back over here. SLT 205. No, SLT. No. CD SLT 2053. Great. Lock tokens at what address? Copy and paste this. And how much? Let's do 7,999,999. Cool. Lock it. Great, no problem. I will be able to watch my mempool and see when this thing is there. But I can also just say Cardano CLI query UTXOs on pre-prod. And we'll query this address. And it's already there. Nice. Mempool is empty. UTXO is on chain. I want to unlock it, but I just created a validator where that's not going to be possible until 15 minutes after the hour. And currently we're at only 8 minutes after the hour. So if I try to build a transaction right now with the current slot of the blockchain, I should have a failing validator. And that'll be a really nice thing to see. So Cardano CLL, query, the tip of pre-prod. There's a nice slot that we can use that's current blockchain time. And let's run script 002. Remember that my validator address is already hard-coded right here. So in this example, all I have to provide is a slot number. Let's do it and run this transaction. And this is exactly what I would hope to see. It failed with an error in the Plutus script evaluation. Beautiful. And now we have 6 minutes to just wait and hope that we can unlock this when the time is right. So, how you feeling? We just covered a lot in a short amount of time, but I'm sure people are having questions. What do you got?
Feel like I need to watch the YouTube video a couple times so I can know what questions to ask.
Good things. Yeah, that's what it's here for. And yeah, whatever parts are most helpful, let us know too, because we can really lean into those. And by practicing, I really appreciate you guys giving me the chance to practice this stuff here, because this gives me a chance to now write it better into the course content.
There was a question that I had. There's two commands that you were running, one where it makes the blueprint and you get that JSON file, and
Yep.
then the Plutus script that basically, I guess, consumes that file and makes it readable to be on chain.
Mhm.
Would there be any reason for, I guess, would you ever need to modify that JSON file, or will you always depend on it being built by Aiken? And the other question is, why not just go straight to like the make it straight to the Plutus and make it, that hex code that it depends on?
Excellent. Yeah, oh, that's my transactions. Right, so Aiken builds this blueprint file, and to get on chain, we need a script file in the certain format, right? So this is interesting and innovative, and it's suggesting a standard that is inconsistently adopted across the Cardano ecosystem right now. And let's go find which SIP this is, because we have a moment to do that. sips.cardano.org. I was guessing it was 59, but I might be wrong. Let's see. Nope, it's not that. Blueprint. There it is, 57. Okay. So, and KTORs, right? That's Matthias dropped by last week, and he's one of the lead developers of Aiken, is writing this blueprint in the first place. Santiago from TX Pipe is really working hard on building compatibility features across Cardano programming languages. So you've heard sometimes we've been talking in the past about UTXO-RPC, and work is ongoing there. This applies a little bit to that. So you can read this yourself, you can see the spec, but just recognize that what we're looking at right here is an implementation of SIP 57 and the standard that it proposes. And that's a really nice way that we can start, right? So not fully adopted, but absolutely adopted by Aiken, and we have a chance to go here. To answer your question, Cesar, I wouldn't I don't think there's ever a reason to manipulate this file by hand, but it will be interesting to try to find if if there is a good reason to. I think this is best, I think this is most helpful when it is auto-generated, because what we really want are tool chains where we don't have to be directly editing files like this. I want to write Aiken build, get this file, and ideally I would just drop this file into my front end project and be able to run from there. That's a future that we haven't quite arrived at yet, but this is a nice step to get us there. The other thing to note here is that if you compare character for character, this compiled code to what actually ends up in the .plutus file, is that they are a little bit different. The first few characters here are a little bit different than the first few characters you see here. And without going into all of those details, one character at a time, the reason that happens is that some of the leading characters are used as a wrapper around the script. And there's a little bit of inconsistency right now across the ecosystem about how Plutus scripts need to be wrapped in order to work with different tooling. What you need to know for now is that the Aiken convert function does properly wrap this compiled code so it can be used with Cardano CLI.
Yeah, that was one of the things that was confusing me a little bit because it looks like the compiled code was like, I think it's like H4 hex or something like that when it actually does get converted, but it turned out to be
Right.
a little bit different. So I
Right.
wasn't sure like the commands that I was running were correct, but I knew yeah, I mean, the process is what it is.
It is what it is, right? And we're still, this is one of those cases of like these standards are still emerging. But one thing you can always do, right? You got this address right here, and this is generated by Aiken Blueprint address directly from the blueprint file. But now that I also have SLT2053.plutus right here, what I can do is I can say Cardano CLI address build. We're going to build an address for pre-prod, and we're going to use the payment script file with this name right here, SLT2053. And one way to confirm that even though the CBOR doesn't match, the contracts do, is to see if we get the same address. And forgive the lack of carriage return, but you can see that this address is the same as this one. So that's a nice inefficient way to just double check if you are ever uncertain, because you can see clearly that the CBOR strings don't match.
I don't know how much time we have. How much time? When is this meeting over?
Well, we're going to be free to unlock that UTXO right now, but I can stick around for a few minutes. What are you thinking?
Okay, no, I was just wondering, like, would there ever be a reason for one validator to reference another validator on chain?
Yes, there are. Yes, and that is where it gets interesting. Okay.
Okay.
And this is where hashes really come in handy. So first of all, a hash, most people know about validator hashes because of minting policies. But the reason we don't just call this a minting policy is because it does have other purposes. I can write a validator that takes your public key hash, for example, as an input. And I can write, so I could very simply write a validator that only you can pull the funds from. That would be trivial. In the very same way that I can use a pub key hash from somebody's wallet to write validation logic, I can use a validator hash like this one to connect one validator to another. An example of this would be a minting contract that only allows you to mint if the minted tokens are sent to a certain validator. Imagine like a faucet. You saw a very trivial example of a faucet at the start of this course, but imagine a faucet where, people can, through whatever reason they want to, mint a bunch of tokens that then go to that faucet and are locked up till a later date. I'm struggling to think of examples off the top of my head, but the biggest one, we use this all the time in Andamio. We have a treasury full of funds that people can commit to tasks from. And when people make a commitment, those funds are stored in escrow. And the way our treasury validator works is nobody can take funds out of it and just place those in their wallet. In order to withdraw funds from the treasury, they must be sent to an approved escrow validator. And the way we tell our treasury validator which escrow validators are in play is by taking the hashes of the escrow validator and feeding those to the treasury validator.
Wow, that's interesting.
Oh, it gets really fun. This is connective tissue. This is how you build an app and not just a standalone validator.
Okay.
Well, enough time has elapsed over here. Last time we ran this command, unlock tokens, with this slot, it failed because the time hadn't arrived yet. Well, let's try it again. Query the tip again. Let's run this script again, but with a slightly later time. I'm pretty sure we are past the deadline. Let's just confirm it. And sure enough, no problem. So that gets us through the essentials of the first 3 lessons, right? We wrote a simple any purpose, all purpose validator that succeeds after a specified time. We looked at how to deploy a reference script so we can use it to start testing some transactions. And then we took a look at a transaction that actually has the spending purpose, which is a bit more rigorous, but as you saw, has a slightly smaller size and therefore a smaller minimum UTXO when we try to deploy it. This sets us up to go through the next 4 examples. These examples are already live in the Git repos, but the lessons are still in progress. And my goal is between now and next Wednesday to draft these lessons just enough and to pretty quickly try to run through these 4 lessons. We got through 3 in almost 2 hours today. I think we can do a similar job. We can get through these close to within the 90 minutes we have for live coding. But if anybody wants a head start, feel free to go explore. And that'll be next Wednesday. At that point, the draft of this course will be complete and we'll be ready to really take on now the maintenance stage of the work where we make sure everything else is up to date. Thanks for hanging out today. Steve, Caesar, Sarah, Seb, still here. Appreciate you guys.
You're a dude.
You're a dude. All right. Well, we've got this guy recorded too, so we can use it however is helpful. Be in touch in the Discord, and thanks for hanging out. See you soon.
All right.